Okay. Imagine 3 baskets. Okay. Imagine 3 baskets, and 1, 2, 4, 8, 16. So this one has 16 here. 1, 4, 5. This one has 13. Okay. So many. So when I write it down in this format, I notice a 1. Okay. At least 1 is odd, so I can remove. So basically this one has to be removed. Okay. I can remove this and make it 0, and then make all these things also 0 by something, but this will still remain 1. I have to leave everything even, so the best thing is to choose this and remove it. Okay. So when I remove it, so that means I am remove 16. So this becomes 0, but still these things are 1s. I can't remove from here, so I can only add. Okay. So that means I am adding, I removed 16, add 8, add 4, add 2, add 1. Agree? So which is equivalent to 1 plus 2 plus 4 plus 8 is only 15. So I am removing 16 and adding 15, which is equivalent to removing 1. And the reason why it works is 1 plus 2 power n minus 1 is 2 power n minus 1. That is the reason why it works. Okay. That's one of the doubts she had. And the second one she wanted to know was on this made triangle, yes? Okay. See, you have a suppose this is 1, this is 2, suppose this is 1. This is on the boundary, okay? This one was 1 and this one was 2, say. This is something inside and this one was 1, and these, they are all adjacent vertices. Because both coordinates of this will be less than or equal to this. Same way, between this you can compare the same way. Agree? Okay. So, this is the old one, this is the new one. So, I need to remove this. I need to remove this and keep this as a base and build another triangle which has the same edge like this one, but one more new vertex. And that vertex must be such that the 3 vertices are adjacent. Okay, the 3 vertices are adjacent, and it should have this as the edge. For example, here is this and this are adjacent. This and this are adjacent. This and this are adjacent, but not this. These two are not adjacent because this one will have one coordinate smaller, another coordinate larger than this one. So the correct adjacent one is not that, but simply fill up this one. This is the new one, because these two are adjacent, these two are adjacent, these two are also adjacent. So from this triangle, its made triangle is this triangle. Okay? So this one, suppose this one has the value, say 2. Then you should remove this 2 and replace it by its made triangle. Okay? So what is the made triangle of that? For example, I remove this. Then with this as the base, I should find a triangle which is this one. Agree? Because these two are adjacent, these two are adjacent, these two are adjacent. So you always move like that. On one side you will be seeing this 2, 2, 2 going, on the other side 1, 1 going, something like that. Okay? Okay, I will move on to. Okay, now I start with a very simple. This is the way basic game theory in all baby courses start. So there are two players. Okay, there are two players. They show 2 or 3 fingers. The player 1 is the row player. Player 2 is the column player in this picture. So you can show 2 or 3 fingers. If the totals, that means they both close their eyes and they can show only 2 or 3 fingers. Okay, they cannot see what the opponent is showing. Okay, they have to close their eyes and show. So if both of them show 2, then 4, which is an even number. So this row player gets 4 rupees. Okay? If it is 2 and 3, the row player loses 5 rupees to the opponent. Namely, the column player gets 5 rupees. You follow me? The same way, 3 and 2, the column player gets 5. 3 and 3, 6, even the row player gets 6. Okay? Now, suppose you play all the time showing 2. It will be a stupid strategy. Suppose I say, if something is good, it is not only good for you, but also you can give a computer or some friend of you to follow your instruction. Suppose you give the instruction, always choose 2. Then the opponent can show 3 fingers and collect 5 rupees from you. Agreed? If you show 2 fingers, opponent can collect 5 fingers from you. So you shouldn't do that. How about half the time showing 2 and half the time showing 3? Is that a good one? Suppose row player, what he does is he tosses an ordinary coin. If the coin falls heads, he will show 2 fingers. If the coin falls tails, he will show 3 fingers. Suppose if he tells the opponent, if player 2 tells, player 1 says, I am going to toss a coin, I myself do not know what's going to be the outcome. All I know is half the time it will be head and half the time it will be tail. So roughly half the time I will be showing 2 fingers and half the time I will be showing 3 fingers. Now knowing this, what should player 2 do? Should he show 2 fingers or should he show 3 fingers? Huh? 2? Okay, now let us look at this. Suppose half the time player 1 gets, half the time he gets 4 if the opponent shows 2 fingers. Suppose opponent shows 2 fingers, let's say opponent shows 2 fingers. So P1 gets 4 half the time because 2 plus 2 is 4. And the other half the time he gets minus 5. Agreed? Which is equivalent to the opponent is making the money. So P1's expected income in the statistics language is half times 4 plus half times minus 5, which is minus half. 2 minus 2 and a half, which is minus half. So if he shows, if player 1 tells player 2, I am going to toss a coin to select to show 4 fingers, 2 fingers or 3 fingers, then if he wants to stick to this one, then player 2 can check what is the most beneficial thing? If he shows 2 fingers all the time, this will be player 1's expectation. If he shows 3 fingers, his expectation will be half the times minus 5, half the times 6. Is it not? Because when he shows 3 fingers, half the times minus 5 and half the times 6, which will be, this is equal to half the times minus 5 plus half the times 6, which is equal to half. So this is actually to player 1's advantage. If player 2 shows 3 fingers, player 1's expectation is half. If he shows 2 fingers, player 1's expectation is minus half. So if you are player 2, you should only show 2 fingers, provided player 1 is telling you that I am going to toss the coin to select. Okay? You got the picture? Okay. Now, this simple problem let's make it one more step. Player 1 has a coin which is not the unbiased coin, it's a biased coin. Okay? So, player 1 says, my coin falls heads with chance P not equal to half. All he says is it's a biased coin. It could be biased in terms of head or it could be biased in terms of tail. Okay? Chance P not equal to half. Okay? With chance for heads. Okay. So I am going to toss that coin, and whatever is the outcome, if it is head, I will show 2 fingers. If it is tail, I will show 3 fingers. He says that. Okay? So one says, I will show 2 fingers if the coin falls heads. Falls heads. I will show 3 fingers if the coin falls tails. Okay? So that's what player 1 has said. He says, I am very sincere. The coin is also very sincere. I am sticking to that. There is no cheating. Now player 2 now has to know, while it may not be P not equal to half, can you tell me what is that P? At least can you give me some idea about that P? He says, I am even willing to tell you the P value. Don't worry, I will tell you. But then, knowing P, what are you going to do? Okay? So now player 2 says, if I knew P, I can evaluate my expectation if I showed 2 fingers. I can also evaluate my expectation if I showed 3 fingers. So, one's expectation when 2 shows 2 fingers is going to, 2 fingers means you are going to get either 4 or minus 5. So 4 with probability P, minus 5 with probability 1 minus P. Agreed? 4 with probability P, minus with probability 1 minus P, which is equal to the expectation is 4P minus 5 times 1 minus P. Agreed? Now this is provided 2 shows 2 fingers. He shows 3 fingers when 2 shows 3 fingers, then the whole numbers will change. Now it will be minus 5 with probability P, plus 6 with probability 1 minus P. So that expectation is minus 5P plus 6 times 1 minus P. Do you follow me? Please stop me if you don't follow this, because this is the baby statistical, baby elementary probability, nothing more. Okay. Now, player 2 has the option to show 2 or 3 fingers. So he would compute this number and this number, compute this number or that number. Which one will he select? Will he show 2 fingers or 3 fingers? Suppose this number is, say, 2.9. Suppose this number is, say, 3.1. Which one will he select? 2.9. Namely, whichever is smaller, that's what he will select. Because he is the loser. He has to pay. Do you follow me? So, let me write down now. Thus, 2 will choose the smaller of this one is what? 4P plus 5P, 9P minus 5. 9P minus 5, and this one is 6 minus, this is 4, 5, 9 minus, yes, 6 minus 11P. Agree? He will choose the smaller of these two. Suppose the smaller is this, then he will show 2 fingers. If the smaller is this, he will show 3 fingers. Okay. Are you with me? Okay. Thus, the guaranteed expectation for player 1, namely the row player, is minimum of these two numbers, 9P minus 5, 6 minus 11P. Do you agree? Player 1 is going to get either this or that, and at worst it will get the minimum of the two. Agreed? Now, player 1 has to tell the P value, then he will do this. So if you are player 1 and if you have to reveal the P value to the opponent, and the opponent will take advantage of this information to give you the least, you follow me? Namely, you have to tell the kind of coin which you are tossing, the biased coin, and tell what is the true probability of head falling, and you allow player 2 to make the decision to give the least based on that P value. Knowing this, now what is the thing which you can do as player 1? This is a function of P. Okay, this is a function of P, so call it as FP. So your aim is to get the maximum possible value for FP. Agree? So one would like to choose that coin P. You can identify the coin with the value of P, okay? That coin P, for which FP has the maximum value. Has the maximum value. Are you with me? Okay. So how do you compute this? I am now going to compute that. The benefit is that is guaranteed. Even though if he has chosen that P for which it gets the maximum value, he can choose that kind of coin and tell the opponent, this is the coin I am using. And then he will try to choose 2 or 3, but still he must shell out at least so much on the average. Okay? So, let us consider the two functions y1 equals 9p minus 5, y2 equals 6 minus 11p. I have two functions. Okay? This is p is always between 0 and 1. When I put p equals 0 on y1, it becomes minus 5. When I put p equals 0, p equals 1, it becomes 4. So y1 is this linear function. This is the function y1. Agree? Now let us plot this function y2. When I put p equals 0, this one is 6. When I put p equals 1, this becomes minus 5. This is the function y2. Okay? I have plotted the two functions. For each value of p, y1 is traveling like this. For each value of p, the y2 is traveling like that. Okay? And here is a cutting point. Now, for each p I take not y1 or y2, but the minimum of y1 and y2. So here is y1 small or y2 small at this point. At this point. Which one is smaller? y1. So it travels like this. Then after this, y2 gets, so it comes down like that. That is our function. So this function fp is this one. Fp is this one. And what is its maximum value at this point? So that means it is the solution of these two equations. At that point p, okay, so when I solve for that one, 9p minus 5 is 6 minus 11p. So part number 20p is equal to 11. So p equals 11 over 20, which is 0.55. Okay? So that means a coin which is biased slightly in favor of heads, it's not exactly half, 0.55. If I choose that coin and toss, and whenever heads I say show 2 fingers, tail I show 3 fingers, no matter what you do, the player must give, what is this value? It's the value where these two are equal, okay, and then substitute this value. Minus 1 over 20. So this game is slightly disadvantageous for player 1. So on the average, if he is facing a very intelligent opponent, he should still be willing to lose roughly 5 cents per game. Roughly 5 cents per game, which is minus 1 over 20. No matter what he does on the average. That doesn't mean you play one game it will, because this is all in expectation. In the long run, do you follow me? In the long run, player 1 must be willing to lose 1 out of 20 games. In some, losing $1 out of 20 trials, something like that. And I wrote down this way. This is, so this one is max min (9p minus 5), 6 minus 11p, minimum over the two functions, maximum over 0 less than or equal to p less than or equal to 1 is minus 1 over 20. Minus 1 over 20. You can now think, why should player 1 alone do this? He says, we have played enough of this. I want you to tell me whether you are going to show 2 fingers or 3 fingers and which kind of coin you are going to toss. So that guy says, I am going to toss a coin which falls heads with chance q and tails with chance 1 minus q, and according to that I will do. So we can rework the same kind of argument. Okay? So there what will happen is, let me write down. Okay. Huh?
I wanted a Minimax.
Yes. Okay. So there he. Huh? What?
In your argument, you said head is more probability. So every time he does head, why does he choose the first? Like, why does he choose to put 2? He can choose to put 3. His gain will be more.
No, he has to tell whenever head falls.
Why can he not choose 3? Because 3
No, he can do that, but he has to tell to the opponent, whenever it is a head, I am doing this. Whenever it is a tail, I am doing that. That information he must tell. But he himself will not know whether it is going to be head or tail. You follow me?
And that minus 120. Suppose he chose 2 for heads.
Yes.
If he chose 3 for heads, his loss would be much lesser because it's 6 and then much more.
No. Say, what is the procedure you have? He is asking, your procedure is, you are telling the opponent, whenever it is head, I am going to show 2 fingers. Whenever it is tail, I am going to show 3 fingers. Okay? Now, the chance for head is p. The chance for tail is 1 minus p. So, when the head comes, I have to show 2 fingers. So, what you are saying is, whenever head comes, why don't you show 3 fingers? That's what you are saying.
Because it is biased.
Huh?
It is more likely to come.
Yeah, head is more likely to come, but your question is, if I had half, for example, it would be even worse. This coin is a better coin than an unbiased coin. When I take the unbiased coin, it was what we noticed was minus half. The expectation was minus half. This one is minus 1 over 20. This is much better. Is there another coin which is better than this coin? No. This is the best coin. This strategy is even unique in this case. Okay? It will sink into you a little later. Okay? There is some confusion. Okay. Now, let's go to the other side, for player 2's side. Okay? He's choosing. 2 says, I toss a coin which falls heads with chance q. If head, I show 2 fingers. If tail, I show 3 fingers. Huh?
Till now, we have only computed all the values from the point of view of player 1.
Player 1. So what we have shown is player 1 can guarantee himself, okay, an expected income of minus 1 over 20. That means his loss cannot be more than 1 over 20. That is what he gets. Now, because this game favors player 2, can player 2 get more than 1 over 20? No. Because of this strategy, of player 1 strategy. Now, player 2, let us see what player 2 does. Player 2 says, if head I show 2 fingers, if tail I show 3 fingers. Okay? Now, suppose 1 shows 2 fingers. Suppose 1 shows 2 fingers. Okay? Then he is going to get, he's showing this. Sorry, yeah? Showing this. Let's, okay. Which one? Middle. Oh, middle one. Oh, this one. Oh. Which one? Oh, right. Okay, thank you. Okay. Now, player 1 says, I am going to, suppose he's thinking of showing 2 fingers, while player 2 his choice is based on the outcome of the toss. So, it is going to be, with probability Q, it will fall head, and when he shows 2 fingers, he will collect 4. It is, with probability 1 minus Q, he will show 3 fingers, he will collect minus 5. Okay? So, suppose 1 shows 2 fingers, his expectation is 4Q plus 5 times 1 minus Q. I'm sorry, plus minus 5 times 1 minus Q. If he shows 3 fingers, suppose 1 shows 3 fingers, his is always player 1. Expectation is minus 5 times Q plus 6 times 1 minus Q. Agree? Q. So these are the 2 numbers which are at the disposal of player 1. He can show 2 fingers and collect so much in expectation. He can show 3 fingers and collect so much in his expectation, which is equivalent to 9Q minus 5 or 6 minus 11Q. Okay, it's either this or that, but player 1 would like to collect the maximum, so he would choose the maximum of this. Okay, and knowing that player 1 will choose to maximize this, player 2 should choose to Q to minimize this. Minimize. No, here it is the maximum of these 2 expressions for each Q. Here is the minimum. Do you follow me? Oh, okay. Now, when you calculate this, it will be the same number. It will be the same number, and again you can check where they are equal, that will be the number. So 20Q is it's the same graph. It is the same graph, it will be this one. This one. Okay? So it's the same point. So that means the players have more or less the same strategy, even. Same strategy. Okay? So this is what is called this min max and that max min, they both coincide and the value is minus 1 over 20. This is for a very simple game. Actually, when 2 by 2 games were raised, Fisher was actually interested as a statistician in randomization in experiments, okay? And then he wanted to study, Fisher was the first person to prove every 2x2 game has such a good strategy. It's even before von Neumann, even before anybody. Fisher was the first person. Fisher, when you think about people like Fisher, von Neumann, they are really maharshis like Vasishtha, Vishwamitra kind. They are mantra drashtas. See, the mantras are revealed to them. They are not worked on that. So it's a remarkable thing. Then we come to the 1 minute. We come to the main theorem. This is the fundamental theorem of game theory. But even before doing this theorem, I don't want that. I want you to appreciate. Okay, let's do this. I want to work out one more game, and slowly, even a guessing game, I want to work out 2 more games. See, the idea must seep in. See, it's not like, it's like in music. See, in music all the notes are there. When you sing, the notes must fall into the right place. They must fall into the right place. Otherwise, it's unmusical. Okay? So the teachers train you again and again to sing the same line again and again. The same way you need to do a few more examples to feel what is going on. Okay? And at the same time, it is curious. Here is an example. There are objects worth 1, 2, 3, 4, 5 rupees. There are 5 objects worth 1, 2, 3, 4, 5. Okay? Randomly one is picked. And is hidden inside a basket. Follow me? I have 5 objects, 1, 2, 3, 4, 5. One of them is randomly selected and it is hidden inside a basket. 2 players, again, 2 players simultaneously, not one first guesses and then the second one guesses after listening to him. No. They both have to write down on a piece of paper, okay, what is the worth of the object. Okay? Guess. Not even what is the worth. Guess an upper bound for the value of the object. Guess an upper bound for the value of the object. Do you follow me? Okay. Who is the winner? A player can win only if he gets an upper bound. A player can win only if he gets the upper bound. If one gets an upper bound and the other not an upper bound, the player who gets the upper bound wins, no matter what it is. You follow me? Okay. If both of them get upper bounds, who wins? The one who is closer to the true value. The one closer to the true value wins. Suppose if both of them gets lower bounds, nobody wins. Okay? Nobody wins. It's a zero. So draw kind of thing. This is the game to be played. You follow me? Okay. What does your intuition say? Suppose you have to make a guess. What will be your guess? You are player 1. Okay? You don't know what player 2 is going to say. What will be your guess? Any feeling? What does your intuition say? It may be wrong, but doesn't matter. Huh? 4? Okay. So her statement is, I will always guess 4. Okay? Huh? 3. Okay. So there are 2 candidates. Your name? Goel, yes? Whatever is. Huh? Shivani, I won't remember. The Goel I will remember. I had a friend by name Goel. Okay. Says 4. Who was the other one? Said 3. Your name? Huh? Ashwata. Akshata. Okay. Says 3. Suppose they play this strategy many times. They don't care for other strategies. They play this strategy many times. Who will be better off? If suppose the number is 1, who is going to win? Huh? Akshata. If it is 2, 3, 4, you. 5, no one. So in 3 cases Akshata will win. In 1 case you will win. So in the long run she is going to be better off. Agree? In the long run she is going to be better off. So between 4 and 3, 3 is better than 4. Okay? Is there somebody who says, I want to try 2? Is there anybody who wants to say 2? Then I say 2. Okay, let's see. Says 2. Now let us compare 2 and 3. Which is better? If it is 1, I will win. If it is 2, I will win. If it is 3, Akshata will win. If it is 4 or 5, neither one is going to win. So that means I have 2 chances. She has only 1. Agreed? So I am better. So 2 is better than 3. 3 is better than 4. How about 2 and 4? Let's compare these 2. If it is 1 or 2, I will win. If it is 3 or 4, you will win. If it is 5, no. So it is a symmetric thing. We have equal power between 2 and 4. So all these things are going back and forth. Okay. Normally 3 is the center, yes? So people tend to feel you should always bid 3. Actually the good strategy is not to use 3. Should avoid 3. That's a good strategy. Why it is, we can work out. Okay? We can work out a little later of the same problem. So a good A good strategy in this case is to say 2/3 of the time, 4 1/3 of the time, something like that. I am not sure whether it is 1/3 2/3 or 2/3 1/3. It is between 2 and 4 only. Don't choose, never choose 1, never choose 5, never choose 3. Avoid all of them. Choose only 2 and 4. And like toss of a coin kind, choose 2 certain proportion, 4 1 minus that proportion. Okay. So this game which what happened? Okay. Now this is a guessing game. There are 3 numbers, 1, 2, 3. Okay? Player 1 chooses one of the numbers. Player 2 must guess what is the number he has chosen. But player 1 will give him signals. What is the signal? If the number is lower, he will say yours is lower than the number I have chosen. If it is higher, yours is higher than the number I have chosen. Then you go another round to make the guess. Again, you will say, if it is correct, you will say stop, the game over. Okay? You continue to guess till you get the correct answer. Okay? Now, I am going to write down this matrix. This matrix represents how to play this game. What does the column say? For example, it says 1, 3 means first guess is 1. Second guess is 3. Based on opponent's information. If it is correct, then you will stop. There is no need for it. See, you are ready to try, everything will be over in 3 rounds. So, if it is second guess is also wrong, third guess is going to be correct. Okay. So, let us look at let's say, for example, let's look at this column. It says player 2, the column player, his first guess will be 1, and in case the opponent says yours is low, his second guess will be 3. Okay. Now, if it is 1, say player 1 has chosen 1, and his first guess is 1, so it's over. The game is over. So, with one guess, he pays 1 rupee to player 1. Player 2 pays 1 rupee to player 1. Here, let us look at this. He chose 2. His first guess was 1. He says yours is too low. Then he went to the other end. He chose 3. Then he says yours is too high. Then he comes to the correct one, 2. So he took 3 trials to come to the correct answer here in this. In this one, he chose 3 first. So he first guess was 1. Then this guy says, oh, yours is low. But then his second guess is 3. Then it became correct. So it is 2. Are you with me? So like that, this entire matrix is filled up. So these are called, each column is called a pure strategy. So let us look at this 2. His first guess is 2. If it is 1, he is going to say 2 is low. No, 2 is high. Then automatically it must be 1. Suppose, let's look at this one. This one. First round he is saying 2. With 3 he will say yours is low. The next round you will come to the correct answer. Like that. All these things are filled. So if that is the case, how would you play this game? Will you play 1, 2, 3 with equal chance? solving such games are quite difficult. This was a struggle even for people like von Neumann. He didn't know, while he proved the main theorem with all the advanced mathematics, he didn't know how to solve a simple game. Okay? And then came another great mathematician, a famous algebraist, and in symmetry he made profound discoveries, Hermann Weyl. Hermann Weyl was also struggling with the same problem. He didn't know how to find the value of a game, how to find good strategies. He didn't know. And then came a guy by name George Danzig. Danzig, when he came, he was, von Neumann had already written a paper on how to solve it by differential equations, which is a really complex nonsense, even for von Neumann. I have read all those papers, and I can tell you how much struggle it is. Okay, it's like prasava vedana, we call it. That means a woman who is up to the 10th, near the 9th month, how she is struggling to produce a child. It's that kind of a struggle he was also going through. But the remarkable thing was, he guessed. Von Neumann guessed. It is all tied to what is called duality theorem of linear programming. He guessed the duality theorem. In a conversation, he told Danzig to work on this duality theorem, and then you will know how to solve it. Okay? Then you will know how to solve it. And then he realized, that's when he realized the power of linear algebra. The power of linear algebra and the notions of linear independence and basic solutions and how it is tied to the geometry. Von Neumann himself, his proof was only by topological methods. In 1937, a French mathematician by name Villet, he realized that the main theorem of game theory can be proved by the so-called separation of convex sets. It's called separation theorem. And then it triggered Danzig to work with von Neumann. But von Neumann was not really keen on anymore doing anything other than giving the general hints. And Danzig was the guy who gave the push for the simplex method. In a sense, simplex method as a powerful method tries to arrive at the solution. Okay? And that's the thing which I would like to talk a little later. How much more time I have? Huh?
Till 1.
Till 1, fine. Okay, 1 minute. No break, nothing. Break is not the thing. See, the other thing is, it's like, what I would say is the following. Ignorance, when we want to remove it, okay, you cannot take, it's like any disease. If you want to cure a disease, you need to take a certain medicine. Agreed? And then the medicine, suppose the medicine has to be taken in small dosage for 3 months. Suppose I try to give everything in 2 days. Agreed? It may not cure the disease. So our ignorance of the subject cannot be removed by a continuous push also. It has to be done a little slowly. Okay? That's all I am saying. Let me guessing game. Okay, okay. Let me try to grind this. Okay? Now, let us first assume the Minimax theorem. What does it say? It says the following. in the previous, it's written in. See, I'm not good at this tech and other stuff. So, 1 minute. Okay. This is a stupid way in which small letters I wrote. Suppose you are given a matrix A, which is called a payoff matrix. Payoff matrix. So player 1 chooses one of these rows. Player 2 chooses one of these columns. If he chooses the ith row and the jth column, Aij is the income to player 1. Okay? Aij is the income to 1 from 2. So 2 must pay 1 Aij. Suppose if it is negative, it is essentially 1 pays that much to 2. Okay. What did I write? Pi. Okay. So player 1 says, I am going to use a random mechanism to select the rows with possibilities P1, P2, Pm. These are the probabilities of selecting the rows. And he tells player 2, I am going to use this probability mechanism. I can tell you what is P1, what is Pm. But actual outcome, I don't know. I'll do the experiment, roulette wheel, and whatever it comes, I'm going to. What comes, I won't tell. That is secret. Agreed? Suppose P4, fourth thing comes. Then I'm going to choose the fourth row. I won't tell which row I'm choosing, but the probability that I'm going to choose the fourth row is P4. That I tell. Okay. Then, player 1 by this P, if it is a good strategy, there is a number called V, called the value of the game. In that 2 and 3 finger mora, the value was -1/20. So, summation Aij Pi, I equals 1 to m. Namely, if player 2 is only going to choose the jth column, player 1 chooses the ith row with this probability. This is the expected income to player 1 if player 2 chooses j. Agreed? If player 2 chooses j, player 1's expected income is summation Aij Pi, I from 1 to m. Are you with me? And I am saying that this must be V, no matter what j is. Independent of what the opponent does, player 1 can guarantee this expected income, called the value. Similarly, suppose he chooses these columns with probability Q1, Q2, Qn, summation Aij, Qj, j equals 1 to n, is less than or equal to V. This one is greater than or equal to V, this one is less than or equal to V, no matter what I is chosen by 1. That means independent of what the opponent does, if only I can choose the jth column with probability Qj, this is the loss for player 2, expected loss. And this expected loss is no more than V. And that V is called the value. That V is called the value. So, in our question, find P and Q. Find P and Q. That's the question. Let us try to solve now there. Not this one. Solve this problem. Okay? So what we are now trying to solve is Think of that as the matrix Aij. Okay? Fix J equals 1. So 1 times P1 plus 2 times P2 plus 3 times P3 must be greater than or equal to B. He is choosing the first column, 1, 2. He is choosing the okay. Player 2 is choosing this. Player 1 is choosing this with probability P1, P2, P3. So his expected income is 1 times P1 plus 2 times P2 plus 3 times P3. And that is at least V. Write down all such inequalities. 1 times P1 plus 3 times P2 plus 2 times P3, 2 and 2. And then P1 plus P2 plus P3 must be equal to 1. And also P1, P2, P3 non-negative. Okay? And what else you want on top of this? We want all these inequalities to be satisfied. Okay? Can you find P1, P2, P3 V satisfying all these inequalities? Any P1, P2, P3 V. Anything. Just anything. Huh? Everything is 1/3. How about V? You can put V equals 0. Say, choose any P and choose V equals 0. It will satisfy all the conditions. Agree? Suppose you put P1 equals 1, 0.2, 0.3 and whatever it is, and put V equals 0, all of them are satisfied. So I have found a solution. But that's not what I want. I want something more. V is the expectation, guaranteed expectation. And what is the aim of player 1? He wants that V to be maximum. So I want to maximize V subject to all these linear inequalities. Do you follow me? I want to maximize V subject to all these linear inequalities. So you can bring also V to the other side and write down greater than or equal to 0, blah, 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 blah. Okay. This is one side. Let's write down the other side. Okay? Q1 plus Q2 plus 2Q3 plus 2Q4 plus 3Q5 must be less than or equal to V. 2Q1. Do you follow me? Or if somebody doesn't follow, please stop me. It should be simply mechanism, something for me. This fellow, he is going to choose these things with probability Q1, Q2, Q5. So if he chooses the first row, this is the expected payment from player 2. He wants to make it sure that it is no more than V. Similarly, 2Q1 plus 3Q2, Q3 plus 3Q4 plus 4 plus 2Q5 must be less than or equal to V. 3Q1 plus Q4 plus Q5 less than or equal to V. Q1, Q2, Q3, Q4, Q5, non-negative, summation 1. Okay? I can as well put V is equal to 10,000 and choose any Q1, Q3 which non-negative 1, it will automatically satisfy. That's no good. What I want is, I want that V to be minimum. So I want to minimize V subject to these constraints. Actually, these are two dual linear programs which von Neumann recognized. Okay, how do we solve this nonsense? Okay, very often, in sometimes, even when you have linear equations, somehow the main idea behind linear programming is replace inequalities by equalities. And you know, yes.
How does it linear programming problem? Because
You are a function of it is a linear function of P1, P2, P3, P4, P5 and V. You bring this V to this side, all these numbers are greater than or equal to 0. So variables are P1, P2, P3, P4, P5 and V. Agree? Okay. First thing is, let us make some guesses, because very often game theoretic tricks are not brutal tricks. You want to exploit some symmetry. Agree? So if player 1 is playing this guessing game, do you think he will show 1 more frequently than 3, or 3 more frequently than 1, or 1 and 3 equal? One more than 3? Because let's look at that. So this is 1, 1, 2, 2, 3. This is 3, 2, 2, 1, 1. What is the big thing? By symmetry, okay, what is 1 can be thought of as 3 and what is 3 can be thought of as 1. So by symmetry I am going to make the bold guess. The good strategy must choose P1 equals P3. Good strategy, guess. P1 equals P3. But P1 plus P2 plus P3 is 1. So P2 is equal to 1 minus P1 plus P3, that means 1 minus 2P1. Agree? So now I can write down those here. So this one I will write this as 3P1, because P1 equals P3. Okay, this one is 4. I will put these things as 4P1. This is only my heuristic guess. I have to prove later. Right now I am assuming this and see whether I can find a consistent solution. Agree? Okay. So this becomes 4. What is this one? 4P1. 2P2. This is 2 times 1 minus 2P1. Is greater than or equal to V. So from this what do I get? V is less than or equal to 2. So that means on the average you won't make more than 2 trials. That's the message which you get. Okay. So this gives you now let us do this one. Is it the same thing? Second one also? Huh? Same thing. This is also giving the same information. How about this? 3P1 plus 3 times P2 is 1 minus 2P1 is greater than or equal to V. This is 3 minus 3P1, 6P1. Am I right? No. Is it this one? Which one I wrote? I wrote wrongly. This one? 3P1. Is this correct? I am wondering. This one. 1p1 plus 3p2, 2p3, yeah, that's correct. So this is 3p1 plus 3 times 1 minus 2p1, 3 minus this one, 3 minus 3p1 is greater than or equal to v. Therefore, 3 minus v, I'm sorry. Okay, that's all I'm getting. And what about, go to this one. 4p1 plus 1 minus 2p1 greater than or equal to v. That means this is 1 plus 2p1 must be greater than or equal to v. See, when you write down all these things, it's a real mess, and you do not know which one to manipulate. Okay, so let me see what I have done there. Okay, 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 okay. Somehow when 2 uses column 2, 3 minus 3p1, 2 chooses column 3, thus b less than or equal to 2v. How did I get v less than or equal to 9 over 5? 4p1. Suddenly I wrote thus. What do you mean? It's very much like my cheating in my college days. See, we used to have problems in partial differential equations. Okay, here is an equation given and here is another equation. Prove this is equal to that. Okay, you are already very confused with the PDE, partial differential equation. You write down some nonsense here and this over that, that over, and then you turn the page, and therefore it simply write down. And the professor, there is no easy way of checking my nonsense. Tick. That's what it looks like for me. How I wrote thus b is less than or equal to 9 over 5. Anyway, this should be part of, you can try this problem, okay, by brute force, not by intelligent methods, by brute force, and try to show that v is actually 9 over 5. If you know that, then you are doing pretty well. Okay, so that's what one should do for this problem. You can actually take this as one of the first assignments. Huh? Yeah, you can add two inequalities when they are on the same side. You can add them, and that's what is needed there. And there are certain things which are called the complementarity conditions, which play a vital role in doing these things. Okay, and that's what I try to make a solution to the example. But I probably, this is just a minute. When 2 uses column 1, 2 minus 2p, 2p1, 3 minus 3p1, 3 plus 2, 5, that's 2p. How do I myself do not know how I wrote that one. Huh?
Multiplying by 2 in the first equation and multiplying by 3 in the second equation.
And then added. Okay, that's what it is. That's what. You are right. That's what it is. Thus, v is less than equal to the other side. You have to show similarly v.
Make sure P1 gets cancelled.
Yes, P gets cancelled. Yeah, P1, whatever it gets cancelled. So so even this little problem has so much of mess in it. Agree? By manipulating or guessing and things like that. But let me. This is what it says. You should guess 1 and 3, player 1, with chance 2/5 each. You should guess 2 1/5 of the time. And exercise, solve this game. Another game, okay? Okay. Nash Equilibrium. Okay. So what I want to do is, even before coming to Nash Equilibrium, I would like to give a brief introduction to extensive games. Okay? I have another 20 minutes. And then you can. A game consists of a bunch of rules, okay, and moves. Let us take a very simple game. Let's take a very simple game. This is the so-called tic-tac-toe. Agreed? 2 players occupy one of these squares. Okay? They do it alternately. If a player can find 3 rows, all in the same row or in the same column or diagonal, that player wins. This is a game which we used to play from elementary school. Okay? While the game per se is trivial, let's look at this game as a game of strategy. Game of strategy. Instead of this, you can identify with 1, 2, 3, 4. 1, 5, 9 is a winning. 2, 3, 5, 7 wins. 4, 5, 6, 1, 2, 3, blah, blah. They win. Agree? Okay. Suppose if a player doesn't want to play, he wants someone else to represent the play. So that means the person must give complete instruction to his representative. I am considering only the first 2 moves. Okay. First move by player 1. Second move by player 2. Okay. Second move by player 2. If player 1 has to give instruction to his representative, what should be an instruction? Think of yourself telling your friend, instead of you, your friend is going to execute your wish. Okay? So, what will be an instruction for player 1? This is a common, just tell me. Pick one. Pick one is not the correct thing. Pick one means you are letting the freedom to your representative. Isn't it? Pick one means you are letting that freedom to be made by him. You want him to obey what you want. So what will be the instruction? You will say pick 7, pick 4, pick 3, whatever it is. Such a thing is a strategy for you, for just first move. It's not a strategy for the whole game, just for the first move. Do you follow me? Now let us take player 2. What will be the instruction? Then namely player 2 is not playing the game. He wants his wish to be followed by the representative. So what will be the instruction? We must write down an instruction. Think of one instruction, for example. Huh? No, pick. No, can you be louder?
The representative of player 1 takes 7.
7.
Then we will ask to choose the adjacent box.
Adjacent means to the left or to the right or top, bottom, which one? So you have to give, he has to give the clear instruction. So that means, if player 1 chose 1, suppose he chose 1, then choose, say, 4. For example, this is a clear. This is an instruction only when player 1 chooses 1. It's an incomplete instruction. So you have to give the instruction also for every one of the cases. If player 1 chose 2, then choose 9. Explicit instruction. If player 1 chose 3, choose 2. If player 1 chose 5, choose 6, 8, something like that. Okay? This is a complete instruction for one move of player 2. Just the very first move of player 2. Okay? This is not even a strategy for the whole game. Agree? Not even a strategy for the whole game. So, you can write this succinctly as a vector. As a vector, x1, x2, x9. Okay? For example, x1's value according to this strategy is 4, x2's value is 9, x3's value is 2, x9's value is 8. Okay? So all these numbers can take the values from 1 to 9. Okay, are they allowed to take all the such possibilities? What are not allowed? Xi cannot be equal to I. Xi is not equal to I. So how many vectors are there? Such vectors. Huh? Huh? 8 to the power 9. Each one can take only 8 values and there are 9 things. 8 to the 9th possible first move strategies for player 2. For this stupid game, that many. Okay? Now you can ask this question. Suppose player 1's representative is playing not only his first move, he also has to play his second move. Okay? How many strategies are there? Let's look at that.
You have to go into like a dictionary, you have to go inside. If he chose 1, then one more strategy.
No. Let's write down the second move. Okay. Okay. Now let's look at the second move of 1. The second move of 1 depends not only on what player 2 is going to do on the first move, it also depends on what he did on his first move. Agreed? So what he did on his first move, okay, that means suppose I1 was his choice on the first move, okay, and if J1 was the choice of player 2 in his first move. Of course, I1 will not be equal to J1. For that pair, you must choose a number which is one of the 7 numbers. Okay? For I1 J1, you choose one of the available 7 numbers. You have to fix it. You have to fix it for each one of them. Agreed? So it will be it will be something like how do I write it? In player 2's first move, okay, it depended on as a function. Okay, it's a function which you wrote it as a vector with. Now this one will have how many coordinates?
9.
Huh?
Only 9 coordinates.
Not 9 coordinates. No, this 9 refers to if player 1 chose 1, what I am doing. If player 1 chose was 2, if player 1, then player 2 does something. He chooses one of the available. So same way, if I chose I1 and if he chose J1, then I am going to do this. I2, J2, blah, 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 like that. So there are 63 or 72. 9 times 8. 72. It is a 72 coordinate vector where each coordinate is taking one of 7 values. Agreed? It's a, say, x11, x12, x13, x19, x21, blah, blah, blah. And each one takes one of the 7 values. Okay? So it is 7 power that many possibilities are there. So the problem of writing a strategy for a simple trivial game which elementary school children play is mind-boggling in terms of when you want to write it down. Agreed? So that much difficulty is there in writing what is a plan, a master plan. So now player 1 has to make a master plan for his first move, his second move, his third move, etc., etc. Then you can imagine. So we never play the game that way. So that means there are lots of reductions by symmetry, which kills many things. Okay, many strategies are the same essentially. Okay, so that's what one deals with, and
Here, where is the
Here,
where is the
where is the
symmetry here in the scheme?
in this, for example, suppose this is chosen by player 1. This is chosen by player 1. For you, whether you choose this or this, or this or this, they are all in some sense, that's the kind of symmetry. And that doesn't necessarily mean that. So normally what we do is when children play the game, you have only 2 options. Suppose you put 7, star. Either you have an option to put on this side or on this side. Either you put here or here or here or here or this. This is a special type. This is a special type. This is one of the corners. This is something inside. Either corner or inside. So that's the kind of symmetry. That's how we play the game actually. That's how we play the game. So next, I think I will stop here now. But next time, I want to start with extensive game, okay, and Kuhn's theorem on games with perfect information. See, whatever is that one and the linear programming. More than linear programming, we'll start with basic solutions and simplex method. You may know simplex. I'm sure some of you probably have already taken a course in simplex. How many of you know simplex method? Okay, so it may be a bore for you, but still you may appreciate it. Okay, little bit for the, I don't know how to otherwise deal with that, because it is the one which is closer to the next topic, namely the Lemke-Hausen algorithm and bimatrix games. But I will spend time on other aspects of games before I come to, because the course must be, in some sense, it must be connected to the matrix theory. See, the strength of matrices must be felt by the students, and the strength of non-negative matrices also must be felt by the students. So their interrelationship will be felt. So if I go in that direction, and also I will deal with extensive games and other examples and everything, as much as I can, this for something like that. Okay, thank you.